welcome back to Azure Terraformer. Today we are going to continue mission on our .NET 6 Azure function. We already set up our Terraform and our GitHub Actions that do a complete CI/CD pipeline for our codebase. Last episode I started doing some C# work to get my function looking a little bit healthier using dependency injection. So I set up my startup class and I injected my first service component into my function, which acts as the entry point to my application. Today I'm going to set up a logging interface such that all of my components will be able to have access to the logs, to write to the logs, so that I can get really good insights into what my application is doing. This is a really important thing to get started right off the bat because, again, just like we're deploying early and often, we also want to log early and often so that we can make sure when things do break, which they're probably not going to break now because everything's really simple, but when things do break, you have that connective tissue already in place and working so that you can rely upon it to go figure out what's going on. So that's what we're going to do today. I think next episode I'm going to dig into how to leverage the App Insights telemetry client using a dependency injection model. But today I think we're going to focus on the ILogger interface, setting that up within our service component. Without further ado, let's get started. So the first thing that I'm going to do is I need to add a NuGet package for the logging abstraction. And I want to make sure that I use version 6. Now that I've done that, I need to go and refactor my function itself. So within my function, I can, because I have this extension right here, the Microsoft extensions.logging, I can just declare a private read-only member of an ILogger of type, whatever type the class is. This is a common pattern of observability within .NET, ASP.NET, all the things. And so using the ILogger interface for your class means that the logs are going to be kind of bound to your desired class, and it'll have diagnostic information coming out of your specific class to help get information out there. And then this pattern is what you're going to see. You'll have this generic ILogger. That interface provides a bunch of methods. It's going to have a type parameter, which is going to be whatever class that you're going to use this from. And then you want to declare a private read-only reference to it. And then you want to inject that thing in the constructor of your class and grab that reference that's coming in through dependency injection and set it to your private member variable. And then from that point forward, you can use that logger to do any logging that you want to do. And so the Azure function, which started off with a static class and a static method, and I've hence converted it to not be static anymore, used to have to do method injection of this generic ILogger. We can get rid of that, and then I can go back here and add use the reference of the ILogger that I've done, and then we can go deploy this code, and we can go see and make sure that the logging still works. So let's go do that.
A few moments later.
Okay, so now that updated version of the code has been deployed, I can go and make sure, let me just refresh my live metrics here. Within your application insights instance, you can go and you can access live metrics, which is going to give you a live feed, a near real-time feed of any logs or events that are happening. You can even see my function starting to kind of boot up. One function found, yada yada. So you get trace information, you get custom events, you get log information, and you also get some kind of health information in terms of the requests coming into all the things that you've attached to this. Of course, this is very, very generic. Azure functions don't actually have a server name, but you can kind of see these kind of random numbers coming through. That's, that ultimately my function is running on some server somewhere. I am being measured based on how much memory I've committed and how much CPU, fractional CPU I'm using. So it's not like the resources don't matter. It's just, I don't have to worry about the underlying infrastructure that's doing it, right? So I do have to somewhat be concerned about how much resources I'm consuming, because ultimately I'm going to pay for that, right? So you don't want to have a function that just spins and does nothing forever, because you're ultimately going to pay for those resources, right? You might not have a VM that deadlocks, but your bill could get pretty high if it just keeps spinning an error. So anyways, let me drop in a Postman and just execute, a request, and my number is 5. We had that alternative version, that alt version of my service that returned 10. I switched it back and I got rid of the alt. So we're just back to that the version of the service component that's returning 5. So now if I go back to my logs here, I can see some trace information here. I don't actually see the log. I guess maybe that's what they're calling as logs, right? So the trace, here's my number 5. So if I go look at my code base, here is my number 5. That is coming from the logger that I just set up. So I know it's coming in it looks like it's coming in from trace right there, but that is coming from my ILogger interface where I'm logging. I can also go over to transaction search, which there will be a little bit of a delay. Let me just put this to the last 30 minutes and see what comes back. And lo and behold, I can see that I do have some things coming back. Looks like a bunch of system messages. So it might take some time for it to get into the transaction search, but I feel pretty confident that because it was in the live metrics, it's coming through. So I feel pretty happy about that. This will eventually show up in my transaction search right here, but I think we're getting closer. So 9:17 is the time that we're looking at. Let's go look for my number 5. So this is from earlier. So it still hasn't come through yet. So it might take some time for that to come through. Anyways, so let's go back to the code. So I've configured my function to use this ILogger. Now let's go and configure my service component to use an ILogger as well. So now, because I'm injecting my bulk request processor, if you recall in my startup here, I'm basically configuring my dependency injection container to say, hey, when somebody requests for this interface, give them an instance of this class, right? One of the benefits of this is that when the .NET runtime attempts to create an instance of this class, if this class itself has dependencies that are defined and declared within the constructor, the .NET framework will the .NET runtime will try and resolve those dependencies for that class. And so if I want to basically what that means is if I want to log within this class, all I need to do is on the constructor of this class, well, first of all, I need a constructor. On the constructor of this class, I need to declare my own ILogger for this class type. So bulk request processor. And then I can, use the same strategy. I need to reference, so I need to add the logging abstractions NuGet package here, right? Version 6, keep it consistent. And then add this, takes a second for Mac to add that reference. Okay, so now I've got that reference incoming. Let's create a private member variable that's read-only. Let's grab that argument that comes in and save it so that we can use it. And now inside here, I'm just going to say logger.log. So now if I go and I push this code base, the CD pipeline is going to trigger again so that we're going to deploy this version of the code. And we will be able to go back to our live metrics and we'll be able to see, in addition to my number is 5, we're going to be able to see that trace event that comes from logging that information from not only from within the function, but from within the service itself. So we'll be able to have, basically we'll be able to log from any class that we implement, as long as we inject that class into some class that uses it using the dependency injection technique. And so while we go wait for that, let me go look here, see if I ever get that trace information. Actually, it looks like we're just 10 seconds away from seeing that telemetry come through. We're at 9:16:47. So we see the request come through. Still don't see that trace yet though. We also need to go into the startup service and add logging.
A few moments later.
Okay, so let's run this request again and see if we can see the logs come through. So that's our buddy right there. That just happened. Now, if we can go through here, see the transaction search, let's see if we can see this come through over there. 9:32:54.
A few moments later.
So the logs are not coming through. I think the thing that I'm missing is probably in my host config. So in my host config, I need to add like a log level section. So underneath this application insight section, I need to say log level. And then I need to say the namespace. And we'll just say GitHub crawler. I guess it's going to be GitHub crawler.GitHub crawler. So let's see if pushing this update will actually allow those logs to come through.
A few moments later.
Now let's come back here and smash Postman, and we see here's my number 5, 9:46. So we're a little bit behind.
A few moments later.
And there we have it. We have the logs now coming through in Application Insights. We had to do a couple of things. So in my code, number one, I had to go to my startup class and I had to add builder.services.addLogging. And I had to go to my host.json and I had to add a log level for the particular namespace to set it at information, which all of these that are coming through are going to be, now that's interesting. Bulk request processor is coming through, but because my host.json specifies this as the namespace, it may not come through. Maybe I just need to set the default. So let's try that. Let's see if that solves the problem. So 1007 definitely has a thing. 1007 number 5 and 1007 bulk request processor do something. Let's see what we can get come through here. I see a lot of information coming through, but I don't see a lot of hi, my number is number 5. So there we go. 1007. I think this is it. So I think this shows that we just solved the problem. 1003 didn't work. 1007 I've got, here's my number 5. Here's my number 5, and I got the bulk request processor do something. So right off the bat, I know that what I did, which is set the default log level of information, is what made this work. Now, there are different ways that I can configure this using namespace, using function, using different special, magic strings that would indicate different segments of the code base that I want to log at a certain level. But I'm just using default, setting it to informational, and seeing what comes through. So I think with that, I'm good to go, because now anywhere that I want to log, as long as I have this ILogger, and we'll go back here and just remind what this pattern looks like. I have this ILogger of type the class that the ILogger is going to be logging from, and then I inject an instance of this, capture it as a private read-only member variable. And then anywhere within this class, when I do logger.log information, logger.log whatever, right? There's lots of different methods: log error, log debug, log critical, log trace, log warning. There's lots of different levels that I can log at depending on what's happening. In this case, I'm just logging information, which is the most low level logging threshold there is. Basically, it's when you want to just flood the system with all sorts of contextual information so that you can figure out what the hell's going on. But this didn't work until I properly configured the host.json to use a log level with a magic string that was scoped, to what I wanted to scope it to, which is everywhere. So default is everywhere. And then in the startup class, I had to add logging. And then within the function, or within any class, really, I just need to inject an ILogger and use that ILogger through a member variable that I capture it so I can use it whenever I want to do whatever logging that I need. And I can do this not only in function classes, but I can do this in any class that I implement, as long as I am injecting the ILogger of the respective class, and as long as I'm injecting whatever concrete implementation that was using my dependency injection. It's going to resolve that ILogger and construct it using the logging factory. So here you go. So this basically sets up Azure Functions observability. We have baseline logging. We just had to configure the host.json. We had to configure the startup to add logging to our builder service. And then we had to configure every component that's going to log to this to use the ILogger interface with a generic type parameter, of whatever class you're going to be doing the logging from, right? And with those powers combined, we are now able to log from anywhere within our .NET 6 Azure Functions solution. So I hope you found this helpful. I did encounter, I think, some pretty common pitfalls that people that are new to Azure Functions, new to .NET 6, new to setting up application insights will run into, right? Not knowing about the host.json, not knowing about the syntax within host.json, not knowing that you need to, configure your services to add logging, and then also noticing kind of this really idiosyncratic, contradiction in that the logs are showing up in the live metrics, but they don't show up in the transaction search, right? That doesn't compute to me. It's really strange that it'll show up in the live metrics, but it won't show up in the transaction search. And so transaction search is really important to verify that it's coming through in a permanent sort of way. Live metrics you cannot rely on in order to verify that your observability is set up. Live metrics is definitely convenient and definitely more up to date, more real time, but just because it's in live metrics doesn't mean it's actually going to get stored in perpetuity, which is really what we care about when we think about application observability. So I hope you found this helpful. If you did, smash that like button and consider subscribing. We got a lot more coming. I'm going to be digging into the telemetry client and seeing how we could create custom events within Azure App Service and within our Azure Functions so that we can track critical and key points of execution, how many times they happen, what the context is when they do happen, so that our operators can get a better understanding of specific transactions and what's going on within them. So I hope you are enjoying this. This was a lot of fun. I'm really enjoying working with Azure Functions again. It's been a little bit while. Again, I think multiple versions of .NET Core have come and gone since the last time I was hands-on keyboard with Azure Functions. But it's you know, it's a good experience kind of coming up to speed and working with this stuff again. It's very useful to get turnkey solutions out of the door quickly using Azure Functions. And I'm looking forward to working with Azure Functions and mashing Azure Functions up with different Azure services like Cosmos DB and the like, and really taking this stuff to the next level. So I hope you're along for the journey. It's going to be fun. I'd love your feedback. If I missed anything within this video or other videos, please let me know in the comment section below. I'm always looking to hone my game a little bit better. So if I'm missing something, I'm out to lunch, absolutely draw my attention to it so that I can get better and we can all get better. And I'll definitely give you a call out when you do. So that's it for me. This is the Azure Terraformer signing off.